welcome. All right, so let's look at another special case of inscribed angles. This is in your notes, and I'm going to have you add some to it. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Let's write in what that means. All right, so in your notes, write that supplementary means to adds to 180 degrees. All right, so ABCD is inscribed in circle E. So that means that it has its vertices. Oh, I'm a little off here. Its vertices are on the circle. All right, so it's an inscribed polygon. So that means that angle A and angle C are supplementary. Angle B and angle D are supplementary. Right? So if we know what angle A is, we can just set A plus C, let's write that in, angle A plus angle C equal to 180 and solve for whatever we're missing. Likewise, angle B and angle D are supplementary. And so if we add angle B plus angle D together, they would equal 180. And you might be thinking, well, why is that? All right, so let's take a look here at the intercepted arcs. Let's look at one set at a time. So let's first look at angle A and angle C. So this is the, best as I can draw it, I guess. This is the intercepted arc for angle A. All right, so that means that since arc DB, actually I should say DCB, arc DCB, can't tell if that's more than 180 degrees, but arc DCB is equal to 2 times angle A. Right, because the arc equals twice the intercepted angle. Now if we look over here and look at angle C, here, oops, I went too far. My shadow was blocking. There we go. Here is the intercepted arc for angle C, and that would be arc DAB. So arc DAB, actually I'm going to write the same color. This goes together. Arc DAB is equal to 2 times angle C. But together, arc DCB plus arc DAB equal 360 degrees. They equal the entire circle. So if the sum of the arcs is the whole circle, and this is an inscribed angle, the angle is always half of the arc. So that would mean that angle A plus angle C would have to be 1/2 of 360, which is 180 degrees. And we can do the same thing with arcs with angle D and angle B. Notice that the intercepted arc for angle B would be arc ADC, and the intercepted arc for angle D, sorry that looks so bad, would be arc ABC. And again, takes up the entire circle. All right? I'm going to get rid of all these arcs that are overlapping one another. All right, so you can add this to your notes so that makes that clear why. All right, now together, if we add up all the angles, angle A plus angle B plus angle C plus angle D have to add up to 360. Because after all, if angle A plus angle C equals 180, and angle B plus angle D equals 180, well, then together the 4 angles would have to add to 360. As a matter of fact, that would always be true anytime you had a quadrilateral. This here is a formula to find the sum of the angles in any quadrilateral. So add this to your notes. So find the sum of the angles, excuse me, I said quadrilateral polygon, for any polygon. Doesn't matter how many sides it has. All right, and that would be the sum is equal to 180 times n minus 2, where n equals the number of sides. All right, so that adds a bit to write, but you actually have some space there on the side. Now you don't have to write this one down. You can write down if you want to. Let's just check with the quadrilateral there. So for a quad, the sum would be 180 times, quadrilateral has 4 sides. That would be 180 times 2, or 360, which is exactly what we got up here. All right, and you might wonder why the 180. You can make triangles out of any polygon, and the number of triangles, so when you connect from one vertex to a non-adjacent vertex, the number of triangles depends on the sides. The number of triangles is always 2 less than the number of sides. So for instance, here with this quadrilateral, I can make 2 triangles. Right? So 4 sides, 2 triangles. That's where the 180 comes in. So add the extra parts to your notes. Pause if you need to. We're going to solve 3 problems, 2 of which are in your notes. Actually, we're going to solve 4 problems, 2 of which in your notes, and 1 is an extra one that I'm giving you. That's reviewing through inscribed and central angles, which would be extremely helpful to have in your notes. The only one that's not in your notes is the one coming up. It's this one. Right, so we want to find the value of x. What do we know? We know that inscribed angles are equal to half of the arc. Now, we don't know the measure, so if we follow angle T out, this is the intercepted arc. And while we don't know the measure of that intercepted arc HMA, we do know the measure of arc HM, and we do know the measure of arc MA, and together arc HM plus arc MA equals arc HMA. So that means that arc HMA is equal to 68 plus 42, or 110 degrees. Right, so now we know the measure of arc HMA. Now, angle HTA, or angle T, is the inscribed angle. Notice the endpoints of the angle, the endpoints of those chords, are on the endpoints of the arc. So that means that angle T is equal to half of arc HMA. So you do need to know how to, and if you need to, draw it out, right? Trace it, follow it so that you can follow it out and solve the problems. Circles is going to be a huge portion of this semester's grade, and if you're having trouble with circles, that's not going to bode well, right? You need to be able to find those measures, and really the mathematics isn't that difficult so long as you see where each angle's intercepted arc is. So angle T is half of arc HMA, which means that angle T equals half of 110 degrees, which is 55 degrees. Now, we just learned on the previous page that two opposite angles are going to be supplementary for an inscribed quad. And let's just point out where we learned that on the previous page. So if we look right back here, any day now. Right, so if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So they're going to add to 180. So angle M, or T, which one? I forgot the name of the angles. I'll have to wait till it turns the page. Yes, angle M and angle T. Angle M and angle T, right, are opposite angles of an inscribed quadrilateral. So that means together angle M and angle T should equal 180 degrees. Let's test that out by first finding the measure of angle HTA. All right, so if we look at angle HTA, together angle HMA and angle HTA equal the entire circle. So that means the measure of angle HTA is equal to 360 degrees minus arc HMA, which would be 360 minus 110, or 250 degrees. So that means that X, which is also angle M, I won't write that down. So X, or angle M, is going to be equal to, so this is, if we follow the angle out, right? It's like it's a mouth, all right? Imagine it's a mouth and it's eating its intercepted arc. Its intercepted arc, right, is on the endpoints of that angle. It's arc HTA. So X here, the inscribed angle, is always half the arc, so it's going to be equal to half of arc HTA. So which is 1/2 of 250. Let me make that neater. Or 125 degrees. Let's see if we get the same answer if we solve it the other way. So we know together angle M plus angle T should add to 180 degrees because they are opposite angles of an inscribed quadrilateral. We know what angle, we found angle T before, that was 55 degrees. This is X. And if we subtract 55 from 180, X is equal to 125 degrees. So now you have two ways to solve it. We could find the arc and then take half the arc, or we can simply just subtract 55 from 180, and we would also get the measure, right? And that's a little faster. Right, so here we worked with an inscribed quadrilateral. We're going to do two more problems working with an inscribed quadrilateral. And these are both in your notes. All right, so given circle with indicated center and inscribed quadrilateral, find X and Y and the angle measures. Now this one over here is actually a harder problem because, why did I change the page? It's going to take forever to change the page back. This one back here was actually a harder problem because we had to find the arc measures first to find the angle measures. This one here is actually a pretty easy problem. See, this was a harder problem. This one here is actually an easier problem because we're just going to use the fact that the opposite angles in an inscribed quadrilateral are supplementary. And that's our new learning anyway. So here we kind of proved it again. Here we're just going to use it. All right, so that means that, and this is in your notes, so just add the work that goes with these problems. So X plus 105 equals 180. Right? Because we know, and it says it right above this, so you don't have to write it again in your notes, but I have it right here. Opposite angles of a quadrilateral inscribed in a circle are supplementary. Oh, you have it in your notes as well. So X plus 105 equals 180. If we subtract 105 from both sides, X is 75 degrees. And there we go. That's all there is to finding X. Now let's find Y. So Y plus 86 equals 180 degrees. If we subtract 86 from both sides, Y is equal to 94 degrees. There we go, we're done. Now the next problem is just a little harder, right, because we have a little solving to do, right, but it's still not that difficult. Now this one's very symmetric. It was pretty obvious that these two go together. Those are opposite, and these are opposite. You just have to be a little bit more careful when it's a little less symmetric like this one. But it's not the next corner. It's not the corner that's next to it. So if you travel along the side to get there, that's not the opposite angle. These two are opposite angles. So that means that 2x plus, just drop those parentheses, it's just telling you the whole measures in degrees, that's all. 2x, oops, move that down a bit, plus x plus 12 has to add to 180 degrees because those are opposite angles in an inscribed quadrilateral. So we can add the like terms together. 2x plus x is 3x. Subtract 12 from both sides. So 3x is 168. And then divide by 3. X is 56. And it's not degrees, right, because we'd plug it back in, right, to get the angle measure. And actually, we'll find the angle measure afterwards just to make sure it worked out. Now let's find y, and these two are opposite. So that means that 4y plus 5y equals 180. 4y plus 5y is 9y. And if we divide by 9, y is 20. Let's find the angle measures and see if that worked out. All right, so here, this one here would be 2 times 50. You know what? I don't have enough space there. So I'll just write the angle measure. 2 times 56 is 112. You can just write the angle measure too. All right, and then across the way, we have x plus 12. That would be 56 plus 12. 56 plus 12 is going to be 68. And notice that 112 plus 68 do equal 180. That checks out. Let's look at the other pair. All right, so 4y is going to be 4 times 20, or 80 degrees. And 5 times 20 is going to be 100 degrees. And notice that checks out as well, because 100 plus 80 equals 180. All right, so looks pretty good. All right, and we are done with this problem. Now the next problem is not going to be special to inscribed quadrilaterals. But before we move on to doing other relationships, I thought let's go back and look at inscribed angles and central angles together and find some measurements of arcs and angles. But this was all there was to solving with inscribed quadrilaterals, is remembering that the angles opposite each other are always going to add to 180, because together their intercepted arcs are the entire circle, and that's why. And there we go. All right, so I gave you notes on this one, and this is good practice because you've got overlapping angles, and now you can outline them too, and to get practice in how to do that, so that when you're solving problems, you won't have trouble. All right, we want arc AD. And by the way, we're given some measurements there. All right, we're given that arc AB is 60 degrees and arc DC is 120 degrees. All right, so arc AD is right here. This, by the way, is the diameter of the circle. And we know a diameter divides a circle in half. So that means that together, arc DC, actually, I'm going to use the blanks to my best advantage. So measure of arc AD would be equal to 180, a semicircle, minus the measure of arc DC. All right, so since DC is 120, that's going to be 60 degrees. There we go. All right, so you can put up both parts of that. And we can label that as 60 degrees, right? Because the measurements that we find are going to be consistent throughout this problem. So now we have another measurement in there. Arc BF. Right, so that would be right here. Notice that AC is not the only diameter, so is DF. That is also a diameter. And the instructions, which were cut out, probably said that. All right, so DF is also a diameter. All right, so that means together, arc AD plus arc AB plus arc BF equal 180 degrees. So that means that BF is equal to 180 minus arcs BA plus arc AD. So that's going to be 180 minus, actually let me put it over here, 180 minus 60 plus 60, which is 180 minus 120, or 60 degrees. I don't know the best way to write this out. I've got double equals, that's all right, that I can't even make. Yeah, let's try it again. I'm going to write it down here. 180 minus 120 equals 60 degrees. No. That's because it glitched. Come on. Come on. Come on. There you go. All right, so now we know this one is 60 degrees. Measure of arc CF. Well, now we got the whole circle, but we also know that AC is a diameter, right? So we could use the fact that CF is equal to 180 minus these two arcs right here. All right, so notice that together arc AB plus arc BF plus arc CF is half a circle. So that would be 180 minus arcs AB, or BA, I'll be consistent, BA, plus BF, which would be 180 minus 60 plus 60, which is 180 minus 120, which is another 60. They liked 60s. All right, the measure of angle COD. That is a central angle. So and if you follow it out, you can see its arc right there. There's the angle. All right, its arc is DC. So this is equal to arc DC, which means that this is 120 degrees. So we can write that down here, 120 degrees. The measure of angle B. This is where it gets a little tricky. I'm going to erase all the writing except I'll put back the measurements. And I will mark again the diameters. So this was a diameter. Oops, so straight. These pens don't exactly glide. And this is a diameter. All right, so these are our two diameters. All right, so, and we had, this was 60, and this was 60, and this was 60. And we want to find the measure of angle B. Well, notice, so what you do is you start at the vertex and follow the angle, intersected the circle, and follow the angle, intercepted the circle. So all of this is the intercepted arc. So the measure of angle B is going to be equal to half of the intercepted arc, which is arc ADC. And we see arc ADC is a is a semicircle. All right? We can see that, right? We go from A to C, that's a diameter. Diameter divides the circle in half, plus 60 plus 120 is 180. So this is going to be equal to half of 180, or 90 degrees. So this is a right angle right here. We want the measure of angle C. All right, so here's angle C. Notice that if you follow the angle out, about, here's the intercepted arc right here between AB. So angle C is going to be equal to half of arc AB, which means that that's going to be equal to 1/2, actually I'm going to put it over here, 1/2 of 60 degrees or 30 degrees. Now to find angle D, right, let's outline that one. Running out of colors. Here's angle D. Follow it till it intersects the circle. Follow, just start at the end, at the vertex. Follow it so it intersects the circle. Now, do you see that our intercepted arc is all of that between the angle? So angle D is equal to half of arc ABF, which means it's 1/2 of 60 plus 60, 120, or 60 degrees. So this is 60 degrees. All right, and now the last one, angle DAB, which is this one here. All right, so if we follow the sides, we see it goes from point D all the way around the circle to point B. So essentially, it's the entire circle besides the two arcs, arc AD and AB. So the measure of angle DAB is equal to half the measure of arc DCB. And arc DCB, let's just write it over here, arc DCB is going to be equal to 120 plus 60 plus 60, or 240 degrees. So angle DAB is 1/2 of 240 degrees, or 120 degrees. And there we go. We have found all of the measurements using central angles and inscribed angles. So thanks for watching, and bye for now.